Welcome to Algebra 1 Fall Semester Study Guide 2018. Here we go. So starting off at the very beginning of the semester when it was easy, but maybe we didn't realize it was easy, we've got solving just regular old linear equations. So the idea is to get the variable by itself. So here I would subtract 15 to start off because it's a plus 15. I do the opposite and subtract 15. Negative 22 plus a negative 15 makes them both more negative, so that's negative 37. Remember that the same sign, you add and keep the sign. But then this negative in front of a, we need to move either by multiplying or dividing by a negative 1, because two negatives cancel out and make a positive. Or it may be that you could just think, oh, if it's a negative a and a negative 37, then that has to mean that really a is a positive 37. However you get there is fine, but typically the way we think of it as math teachers or mathematicians is that you're actually moving the negative with multiplication or division. On the second one here, we've got a variable on each side, so one of our first things to do would be to get them together by adding or subtracting. It doesn't matter which direction you go, but typically we try to add it the direction that will give us positives, because positives are easier to work with. So add the 6x over, and at the same time or on a later step we also can subtract the number over to the right side, and so it just kind of depends on if you think to do it on the same step or if doing them on the same step, if that's like too big of a leap for you, then separate them out into two separate steps. But we end up with x equals 10. On both of these we can check our answer by plugging it back in. So if I did negative 37 here, so where a is, I'm going to put 37. Negative 37 plus 15, does that really equal negative 22? And it does, because that's how adding and subtracting works. Or here it'd be a little bit more complicated. I'd have to say negative 3 times 10 plus 5 equals negative 6 times 10 plus 35. And so negative 30 plus 5 gives me negative 25. Negative 60 plus 35 also gives me negative 25, so I have done it correctly. And it's nice, especially with a big exam, to know for sure whether you've done something right or not, so that's why checking your answers is helpful. So number 3, solve the proportion. We want to, we can either think of this like cross multiplying, or you can just think about it like multiplying by 7 on each side. If we think about it like cross multiplying, we would do 5 times 7, which is 35, and 3 times n, which is 3n, and then we would finish by dividing by 3. Since this is multiple choice, we should be able to see our answer choice pretty quickly. And our answer choices also are letting us know kind of the format that we should be answering in, that these are improper fractions, not mixed numbers, so there's no need to change it to a mixed number. Number 4, which of the following expressions has 3 terms and a coefficient of negative 7? So terms refers to, well, terms are separated by positives and negatives. So for instance, A here has 1 term and then another term. So A can't be it. B has 3 terms, C has 1 term, and D has 3 terms. So out of B and D, we want to pick the one with a coefficient of negative 7. So this is really a vocabulary issue. Coefficient is the number that's in front of x, or x squared, or whatever. It doesn't actually matter what it's in front of, but there should basically be a negative 7 somewhere in our answer, and so that happens on B, not D. None of these have a negative 7 in front, and so that is why we'd pick B. Trying to scroll up here. All right. So number 5, we've got parentheses so that we can distribute. That's basically what it's checking that we can do, is distribute and add like terms. So 3 times a is 3a, 3 times negative 2 is negative 6. And then we're going to distribute for this parentheses as well. Negative 5 times 7 is negative 35. Negative 5 times negative 2c is plus 10c. So the 3a and the 10c can't add together, but the negative 6 and the negative 35 can. And if we look at our answer choices, there's a couple issues. Like, you could actually pick out that this is the right answer because of the 3a and the 10c, and then double check and say, -6 plus -35 really is -41. And the problem with that is you might see the 3a and then maybe you didn't remember to distribute, so maybe you think the -2c is correct. The 29 would come from adding incorrectly these two negative numbers. So just because something's multiple choice, you do want to be careful about how much you rely on, oh, look, I did half the problem and I found the answer that I think is correct. If you will do the whole problem, sometimes that will help you see that you've got a mistake somewhere. All right, Bernard works at a pizza place and earns $15 per hour. On Tuesday, he worked P hours. So if we just wanted to know how much he makes at the pizza place, we would have to multiply those together. In case you haven't had a job before, that's how that works. It's how much you make per hour times the hours you work. And then his brother pays him $10 per hour for math tutoring for T hours. So 10 times T. And then it says, which expression best represents the amount Bernard earned on Tuesday? So we would want to add these together. And so that means that 15p plus 10t is what we're looking for, which is C. On 7, write an equation that fits the following description. Do not solve the equation. So the keyword here, or one of our keywords here, is difference. Difference needs subtraction. When it says a number, it wants us to put a variable like in or x or something. And is means equals. So the difference of a number and 10 means that we're going to subtract in and 10. And the order does matter. That if it says difference, we want to put it in the order that it comes in the problem and not switch it around. And then we put equals, and then we put 19. Now, this is actually a really easy equation to solve, but that's not what they asked us for. They just want us to set it up. So we're done. Number 8, the equation a teacher uses to calculate grades is this equation right here, where T is the average test grade and H is the average homework grade. What does the equation solve for H? Now, because these are decimals, this could get a little weird. So I'm trying to get this H by itself. And one of the things that would be helpful actually is to clear out these decimals. And to do that, I would times everything by 10. So that I would get 10g equals 2t plus 8h. And now this is going to be a little bit easier to solve. I would subtract 2t because I'm trying to get the h alone. That gives me 10g minus 2t, which does not actually subtract. We keep those separate from each other. And then I would divide everything by 8 so that I get h equals. Now, if all three of these numbers divide, we can simplify, or we can just separate them into two fractions. That actually sounds better. We'd write 10g over 8 minus 2t over 8, and then simplify. So h equals 5/4 g minus 1/4 t. And that would be our answer. There's some different ways we could write that instead, but this would be one way. Like, for one thing, typically if it gives us decimals, we should answer in decimals. So 5/4 as a decimal is 1.25, and 1/4 is just regular 0.25. So that sort of thing. That actually is probably our best answer because it looks the most like how we started with the decimals. Number 9, solve and graph the following inequality on a number line. So not on an XY coordinate plane, but just on a regular number line. Now, I didn't provide a number line because I personally, as a teacher, don't require much more than just like a single number on a number line. So I feel like it's just as easy for you to draw it as for me to create it in Word, which is not super easy. So that was my reasoning there. So we'd start off by trying to get x by itself, so subtract 9 over, and then divide by -6. And the thing we have to remember about inequalities, or at least one of the things that we have to remember about inequalities, is that when we divide or multiply by a negative, it flips the inequality symbol, so that this is x is greater than -3, that's our solved answer. Now let's draw our number line. So I'm going to put -3. Since it's greater than but not equal to, I'm going to put an open circle. And then I'm going to shade to the right. And there's my inequality. So greater than -3, remember, is the numbers this way, like -2 or all the way over here 0. Those numbers are greater than -3. Or if your variable's on the left side, then the inequality actually points you the direction that you want to shade. So those are a couple ways that we can do that. Let's look at number 10. We've got a decimal here, which could end up being annoying, but let's just see it through. We want to add 2 to both sides. So 3.5x is less than or equal to 21. I don't know if I actually said this on number 9, that the open circle, yeah, I think I said this. The open circle is because it's not equal to. So when we graph this one, it'll be a filled in circle because this one is equal to. I'm going to divide by 3.5. And the way I think of this is I think, well, 3.5 is half of 7, and 7 goes into 21 3 times, and so I need it to go in double that, so this is 6. There are other ways that may be easier to do it than trying to think about it that way, like if all else fails, come over here to the side and do some division. And so you would although you're basically just guessing and checking at that point. So 6 is a pretty good idea of where to start with your guess and check anyway, that 3 times 6 is 18, which is smaller than 21, but also pretty close to 21. Now for our number line, I'm going to put a 6. I'm going to put a filled in circle here at 6. And then I'm going to think less than is to the left. And that's my answer. 11 and 12 are solving compound inequalities, or creating and solving compound inequalities. So these are both ands. So when it's in the middle like this and you just have one inequality, this is saying that 2 things are true, that x is going to be in the middle, and so it should graph like what this one has, just our dots are going to be opposite. Let me show you what I mean. So if we just look at the middle and think, how do I get the x by itself? I hopefully would say, oh, let me add 12. But then where we add 12 is on the left side and the right side. So we're adding 12 everywhere. We're adding it in the middle to get these to cancel, but we're adding it on either side to keep our inequality balanced. And then we're going to do the same thing with the 4 in front of x. When I divide by 4, everything divides by 4. And so that means that 1 is less than or equal to x, which is less than 8. And so then I'm going to draw my number line, and I'm going to put a 1 and an 8. At 1, I need a filled in circle. And at 8, I need an open circle. And I'm going to shade in between them. Now the other thing that could happen to us is they can have 2 inequalities and they can write or between them. So so these boxes that I've left are for you to put things to help you remember. Like maybe we've got 2x is less than 4, or 3x is greater than 18. So the or is going to tell us that these should shade apart from each other, that when I divide by 2, I get x is less than 2. When I divide by 3, I get x is greater than 6. So when I graph this, I've got a 2 and a 6, and so I'm shading to the left of 2, but I'm shading to the right of 6. So anytime you see an or if you see them shaded away from each other, that's what's happening, is that this is an or situation. 12. So now they give us an inequality and want us to write it out. So this is an and so either we can write it together like how we have this answer right here, or you can write two separate inequalities and just put an and in between. So if I want to do it the first way, I would write 1 is less than because of the open dot, and then I'm going to put x, and then I'm going to put less than or equal to because of the filled in circle, and then I'm going to put 6. So knowing whether or not to put the line underneath has to do with the kind of dot at each point. And then what can be weird to understand at first is why these are both less than symbols, and it's because you have to actually read this one backwards. We're saying that x is bigger than 1 because the bigger side is pointed towards the x. So remember back in the day whenever your teacher was like, it's like a crocodile that eats the bigger number, or an alligator, or whatever thing that has a mouth and eats the bigger number. We're saying that x is bigger than 1 because that's where our shading is, and so the bigger side has to be pointed towards x. If you point it the other way, you're incorrect. The other way to do it is just to write separately x has to be bigger than 1 and x has to be less than or equal to 6. And these actually mean the exact same thing. Just when we write them together, if we want to put these x's in the middle, then we have to flip this inequality and make it a less than. So that's how that works. Understanding relations and functions. So we've got 3 different problems with this, and it's different ways that we represent relations. So we can represent it with a set of points or ordered pairs, like on 13. 14 uses a mapping and also asks us about domain and range. And then 15 gives us a graph. So what we need to remember about functions is that each input has a unique output. So for points, what that means is if your x value repeats, then it's not a function, because if I have more than one place where the x values are the same, then my outputs are not the same, then we're saying that 1 goes to 2 things. 1 goes to 2, but 1 also goes to 5. And so that's not a function. It's a relation, but it's not a function. So in this case, A was our answer because that's the one that doesn't work. The rest of these are all okay. And notice it doesn't actually matter if the y value repeats. All we care about is the x value repeating. So not a function if the x value repeats. And that is specifically with points that helps us. If we're looking at a mapping, then hopefully it's easier. Do any of these values go to more than 1 point? Yes, 1 goes to 4 and 5. So no, it's not a function. The domain and the range, so if we remember what those words mean, domain is our input and range is our output. So our domain is 1, 2, and 3, and our range is 4, 5, 6, and 7. And it doesn't say input and output, but look how our arrows are going. That since it's going from left to right, 1 is going to 4. So 1 is what we're inputting and 4 is what we're getting out. 15. Is the graph shown below a function? So we use the vertical line test for this. So the vertical line test says that if I draw a vertical line anywhere on this graph, if it goes through more than once, then this is not a function. Anywhere I put a vertical line, though, on this graph, it only goes through once. And that has to be true for the whole graph, that if there's any place that it would fail the vertical line test, then it fails just overall. Even if it was just like a teeny tiny place where over here, like maybe it looped back a little, that would be bad and it wouldn't be a function. So is the graph shown below a function? Yes. And our explanation is because it passed the vertical line test. Or you could say something about each input only having one output, and that would work as well. 16, so arithmetic sequences. We've got a table here, it asks us to write a recursive rule, an explicit rule, and then it asks us to basically find the term for the 20th spot. So this is going to take us remembering how to write these rules. The recursive rule, we always have to say what the first term is. So f of 1 equals 22. We always have to include that part. And then separate from that, we're going to write the actual rule for the rest of it. So f of n, which is a general number, is going to equal f of n minus 1. Remember, this part is talking about the previous term. So if I want to figure out how to get to 30, I have to think about what I'm adding from 22 to get to 30, which is 8. So I'm going to put a plus 8 out here. A lot of this you just have to memorize. This part will be the same on every single one. This part will be the same on every single one. What you're doing differently is you're plugging in the first term, the 22, and you're plugging in the common difference, which is 8. Everything else about this will be the same each time you do it. For part B, when I write an explicit rule for the sequence, now that we've gone over slope-intercept form, you may notice a similarity there, but instead of using y and x, we're going to use f of n and n. F of n equals the change from 22 to 30, which is 8, times n. And then to figure out what is here, which is like our y-intercept, we have to go back one and think about what would happen at 0. So we have to subtract 8, which would give us 14. So that would be plus 14. There's another way to do it where you just memorize a formula. And in that one, you take the first term, which is 22, and then you add to that 8 times n minus 1. That also works. So these are the two ways we could write our answer. And if you distribute on the second way, you distribute the 8 and add the numbers together, you'll get the same thing as what we have. But again, you're going to likely have to memorize some of this and how we do it, or relate the explicit rule to slope-intercept form and how the slope has to do with how much we are changing each time, and the y-intercept has to do with what we start with, which is what happens at 0. How much will Zoe be paid if she works 20 hours? That is easier to do by plugging into the explicit rule than the recursive rule. And it's easier to plug it into the explicit rule if we have the explicit rule than it would be to continue our table to the 20th hour. So we're finding when n is 20, so f of 20 equals 8 times 20 plus 14, which is 160 plus 14, which is 174. And this would be in dollars. So she gets paid $174 if she works 20 hours. 17 might sneak up on you here over to the side. Does each sequence have a common difference of 5? So that has to do with how much you're adding to get to the next number. And so 25, if I subtract 5, I get 20, but it says a common difference of positive 5, so that's a no. And then here 2 plus 5 is 7, 7 plus 5 is 12, so this is a yes. And then on C, 3 plus 5 is not 15. What's happening on C is they're multiplying by 5, but that's not what we want to have happen for an arithmetic sequence. So, well, for a sequence with a common difference. If we were talking about a common multiplication, that would be different. Moving right along, 5.2, using intercepts. So it asks us, what is the x-intercept of the line graph below? So the x-axis is our horizontal axis. I just need to figure out what this number is. Now these numbers are kind of tiny, so if all else fails, count. This is -1, -2, -3. So our answer here is that our x-intercept is -3. That's not too hard. But 19 asks us, do each of these describe a line with a y-intercept of 4? Now, in order for us to know what the y-intercept is, we need to think about there being a 0 where y is. No, just kidding, where x is. It's backwards. It was a fun joke. Okay, so we need to think about there being a 0 where x is, and so -3 times 0 would go away, and we just need to think, if I subtract 12 over to solve for y, do I get 4? And I do not. I get -4. So this is a no. That's what we're going to do on each of these, is we're going to put a 0 where x is. We called this the cover-up method when we did it in class, that when you put the 0 where x is, it actually, you can cover that whole part up. Okay, I need to subtract 2, and I get 14. That's also not 4. And then here I cover up the negative 2x, and I don't even have to do anything to solve this. Y really does equal 4. That also was kind of, sort of, in slope-intercept form, and so it might have been really easy for you to tell that it is, that the 4 really was the y-intercept. When you're using intercepts, you might make a note that the y-intercept is when x is 0, and then the x-intercept is when y is 0. So they're opposites, and that is what lets us actually solve for the letter that we want. Interpreting rate of change and slope. So a couple of things to remember here. One is slope is rise over run. Or another way to do it is to write down your slope formula, which is y2 minus y1 over x2 minus x1. And so it depends on, like, if they give us a graph, then thinking about rise over run is easier. If they give us points, then the slope formula is easier. And also the other thing to remember, and this is just a general tip, is 0 over a number, no matter what number it is, as long as it's not 0, is okay and equals 0. But if our number is on top and our 0 is on bottom, then that means it's undefined. So if we're working it out and we get 0 on top, that's okay, that's 0. If we get 0 on bottom, not okay, that's called undefined, that we can't actually find the answer to that. So 20 says, what best describes the slope of the line shown on the graph below? Well, if I think about rise over run, it doesn't rise at all. It rises 0, and it runs, you can pick whatever number you want. It runs 1, it runs 2, it runs 3, it runs negative 10, but it does run. It's not a 0 on bottom, it's just a 0 on top, and so that is 0. An undefined slope would be a vertical line. Let's pretend this is a straight line. Okay, a vertical line is undefined because then it's all rise and no run, and so that makes there be a 0 on bottom instead of on top. I also like to make the analogy of a skier. I personally am not a fan of cross-country skiing, although I know that some people are. And so if this person was skiing on this line, if I was skiing on this line, I would have 0 fun because I'd be having to push myself the whole way. Whereas if I was skiing on this undefined slope, I would have an undefined amount of fun, and you can take that to mean whatever you want it to mean. 21. So this is where we've got 2 options. We can just count if we're into that sort of thing. And I even made it to where you should be able to see these like 2 points kind of clearly, that these are good points to use. If it doesn't mark points for you yourself, you want to pick things that go through the actual grid lines. And so like this is not a great point right here because it doesn't go through the grid lines. This is close but still not good. This one would work if we needed another point to use. So counting the rise over the run, I want to count 1, 2, 3. I went down 3, and 1, 2, 3, 4 over 4. And it really depends on kind of which direction you do this between the points, but one of the directions is negative and one of them is positive, which overall gives us a negative answer. Also, all negative slopes go down to the right, all positive slopes go up to the right, so that's another way to remember. If for whatever reason you wanted to use the slope formula instead, you have to label these points 0, -1, and 4, -4. And then we would use our slope formula, y2 minus y1 over x2 minus x1. We're going to have that happen at some point in a moment, so I don't really want to do that on this problem. We're about to do it on 22. So slope-intercept form is y equals mx plus b. And so we've got 2 points here. We were not told the slope, but we can find the slope of the line that goes through these 2 points using the slope formula. And so the slope formula is just a fancy way of saying subtract your x's over subtracting your y's. Now the problem is that if I do 2 minus -2, I'm actually needing to add those. And that's the thing that people forget a lot, is that subtracting a negative is really addition. -6 minus 4 is -10, and 2 plus 2 is 4, and that simplifies to be -5/2. If I look at my answer choices, I actually already can know the answer is A. If I wanted to keep going to find B to like check that I've got this right, what I would do is plug the -5/2 into slope-intercept form where the m is, and I'd pick one of the 2 points to plug in for x and y, and then solve for b. So if I pick the first point, it would be 4 equals -5/2 times -2 plus b. So here I would do the 2's canceling out. The 2's would cancel, and I'd still have this negative to multiply, like a -1. This would be a -1 times a -5, which is a +5. So 4 equals 5 plus b. I would subtract 5 on both sides, and b equals -1. So that's more confirmation then that we got the right answer. Although, if you got the slope wrong, then you probably wouldn't get the y-intercept right. So as long as all the slopes are different, your best bet is to try to get one of the answer choices just from the slope. You also, I mean, there are other things you could do. You could graph the 2 points and look at the slope and the y-intercept that way. And that would be a fairly, if you have graph paper, that'd be a pretty good way of doing it. So lots of options. 23, the table below shows the relationship between the number of hours traveled on a road trip and the number of miles driven. It asks us to write a linear equation in slope-intercept form that describes the relationship in terms of x and y. This is actually just like what we just did with the explicit rule. And so we are going to do y equals, m is our slope. So how much am I changing for my y's over how much am I changing for my x's? So this would be 180 on top is how much I'm changing for y, and on bottom how much I'm changing for x is 3. So my slope is 60. So 60x. And then for our y-intercept, we need to think about what's happening at 0. So if these are all going up by 3, then if I just go backwards 3, then I should be able to see what the right answer is here. Or if you want to use this 60, well, that's happening, you have to go back 63 times to get to 0. So in other words, I'm subtracting 180, which gives me 0. So my y-intercept is 0. That means we don't actually have to include that. You can just say y equals 60x. Another way of thinking of it would be to say, what's the relationship between 3 and 180? What's the relationship between 6 and 360? I'm multiplying by 60 each time, and so that gives me y equals 60x. So part B says, how many miles are driven per hour? Well, if you have 180 miles in 3 hours, your miles per hour are the simplification of that, which is what we got for the slope. So m is giving us the same thing as miles per hour. So 60 miles per hour. How far will the car have traveled at 20 hours? Well, we would take our equation and plug in 20. So 60 times 20 is 12 with 2 zeros, so 1200. And my units here would be miles. That's kind of a tough one. So it is helpful to relate this to some of the other things we've done, like explicit rule, and just thinking about these. If it helps to think of these as points, that this is 3, 180, and this is 6, 360. And so what you can do is use slope-intercept form or point-slope form to figure this out. You can use the slope formula to help you find the slope. So lots of options of what we can relate this to. 24. In order for us to find the equation that matches, since our equations on our answer choices are all in slope-intercept form, We need to find the y-intercept, which is right here and is -1. And then we also need to find the slope. Now, the points weren't given to us, so this looks like a good point. Up 3 and right 4. So I'm looking for a slope of 3/4. Oh, a slope of 3/4 and a y-intercept of -1. Well, that's awkward because that's not an answer choice. So let's just make ourselves an answer choice. E 3/4 x minus 1. Whoops. All right, number 25. We are writing an equation in point slope form for a line that passes through 1, 4 and -2, 2. Got point slope written over here, and I have these arrows to point out that our answer should have y and then a number for our slope, and then should have x and then a number plus either y plus something or y minus something, x plus something or x minus something. But the y and x in our answer will be an x and a y. The x1 and the y1 and the m is what we're going to change based on the problem. So they gave us 2 points, which means we can find the slope. If they just gave us the slope instead, that would be helpful. That would make this problem super duper easy, but we're going to have to find the slope ourselves. And so to find the slope, we use the slope formula, x1, y1, x2, y2. And so we're going to do 2 minus 4, y2 minus y1, and then on the bottom, it's important because I actually made the mistake earlier as well. We want to do x2 minus x1. So whatever order you subtract on top, that's the order you need to subtract on bottom. So the fact that I used this 2 first means I need to use this -2 first as well. And that the difference between the two situations is typically just that you get the sign wrong. You get a negative when you should have gotten a positive, or the other way around. So I get -2 over -3, which is a positive 2/3. And then that's what m is. And so then I just need to fill the x1 and the y1 in with either point, whichever one I want to. If I pick the first point, I would do y minus 4. That minus sign is because our formula has a minus sign. And then 2/3. And then x minus 1, or we could use the other point, and so in that point we would use this 2 for our y minus 2, and then when we use the x, since it's already a -2 and we're supposed to subtract it, that's going to change to a +2. So that's the thing that's kind of tricky with point slope, is the formula itself has negatives, and so when we plug in our point, if it's a positive, it makes you do minus that, but if it's a negative, it makes you do plus that. So whatever it is, it ends up being the opposite. 26, graph the inequality. So some things to remember here, less than or equal to mean to shade below, while greater than or equal to mean to shade above. I don't know why I decided to write it out once and put an arrow on the other. Less than or greater than are a dashed line. Less than or equal to or greater than or equal to are a solid line. And remember that when you multiply or divide by a negative, it flips the inequality. Okay. So this is solved already for us. Y is less than 1/4 x minus 3. So I just need to put the -3 right here and then go up 1 and right 4. And I like to go both directions personally to make my line look nicer. This is a dashed line because if I look at my inequality, it is not equal to for my inequality. And then since it is less than, I want to shade below. So that's down here. And that's my answer. Now, moving on to systems of equations, which is the thing that we've done most recently, which is why it's at the end here. This is graph and solve. So the first one's in slope-intercept form. So we'd start at -4. I'd try to go down 5 and right 2, but not be able to. So I'm going to go up 5 and left 2. So this is a thing that people forget a lot. the negative has to go on top or on bottom. And if you don't have room to go one way, or if it doesn't help you to go that way because your intersection point isn't that direction, then we go the other direction instead. And these are equal signs, so we do solid lines. And we are trying to find where these two lines intersect. The second one is almost in slope-intercept form, but not quite. We got to add the 3 over. So y equals x plus 3. And if it helps, this is a 1x. And so our slope is up 1 over 1. Now, if I start at 3, and I go up 1 and right 1 because it's positive, continuing to go that direction doesn't help me. I need to go the other direction, which is if they were both negative. And we can do that because 2 negatives make a positive. All right, so our point here is -2, 1. And so that's our answer. 28 probably seems a little tricky at first because we haven't seen the question phrased quite this way. But it says, how many solutions does the system that they give you have? A says none. That would be like if we get no solution. And D says infinitely many, so that's like if we get infinitely many solutions. Getting exactly one solution would be like what happened here where we got an answer. We don't have a situation that we've encountered that would give us exactly 2. That would imply that something is going through our line more than once. And we haven't talked about how to do that yet. That'll happen later on in our math career. So what I want to do is get far enough in solving the system that I'll know, am I going to get an answer, am I going to get no solution, or am I going to get infinitely many solutions? So how am I going to do that? I am thinking that solving for y might be the easiest way to go about it. And my reasoning is that if I think about how graphically no solution is parallel lines, and parallel lines have the same slope, or that graphically if it ends up being the same line, then they are infinitely many. I feel like that would be helpful. But really you could solve this however you want, or I could add the 3 over so that I know what y equals, and I could do substitution. That would be an option. Like I could put the 6x plus 3 right there. Let's do that actually. I changed my mind about graphing. I'm putting the 6x plus 3 where the y is in the second equation. So I know that these fractions can seem intimidating, but this is going to actually work out really nicely right here. So 1/3 times 6 over 1 gives you 2x. And then 1/3 times 3 over 1 gives you 1. And so hopefully we can start to see which answer we're going to pick, because 2x plus 1 equals 2x minus 4 over 7. Is that true? No, it's not. And if you subtract 2x from both sides, you see that that cancels. 1 does not equal -4/7, so that's our clue that this is no solution. If we had gotten 1 equals 1, then that would mean there were infinitely many solutions. If we wanted to try to use elimination, that would be tricky here because of fractions. Really trying to graph or multiplying the second equation by 3 to start off, or even better by 21 to get rid of the fractions might have helped us out. Or, you know, it's multiple choice. You could just guess, but don't guess exactly 2, because if you're in Algebra 1, you probably haven't done problems that give you 2 solutions. The next 2 questions ask us to solve using substitution or elimination. And so you're free to pick either the same one both times, or like it's intended that I don't want you to graph it, and you don't have graph paper, so hopefully you weren't planning to graph it anyway. But one of these is set up that if you wanted to use substitution, it'd be relatively easy. That would be this one where y is by itself. But this other one, substitution is not a great idea. You really need to use elimination. Yeah, elimination. So it's up to you. I'm going to go ahead and use substitution on this one just to show a problem with substitution. I guess I just did a substitution one, but I'll do another one. It just gets, neglected sometimes if we're not careful. I'm going to put that in for this other y, the 3x plus 12. So 2x minus 7 times 3x plus 12 equals 11. The majority of issues that happen on these because they're kind of long problems is people not doing their positive and negative rules correctly. So if you get to a point where you're like, this doesn't seem like it's going well, go back and check your positives and negatives. This, for instance, makes negative 19x. And I add 84 over and get 95. So then I divide by negative 19 and get a negative 5. And then I plug that back in. This is a good place to do that, although anywhere will work. So negative 15 plus 12 is, oops, negative 3. So my answer is negative 5 comma negative 3. And if you, like, the problem with substitution is if it's easy to use substitution to do it, it's easy to do elimination. You could have times the first one by 3 and the second one by 2, or you could have just times the second one by 7, and you would get exactly what we had. So, whichever. Now, elimination on 30. I want to think of either in front of x or in front of y a way to get the same number. So it seems easiest right here to times by 2. And so that's going to give me 4x plus 10y equals 52. And then I'm going to ignore this equation and add the first and the third equation. So the x's cancel, and I get 16y equals 64. So I divide both sides by 16. And I get that y equals 4. Then I plug that back in. When I plug it back in, I need to pretend like I didn't mark all this out. So any of these three are fine to use. I just need to decide which one I want to pick. I like to pick the first one personally, but it really doesn't matter. So negative 4x plus 24 equals 12. Then I subtract 24. And this is why the first two problems where you're solving really simple equations should seem pretty easy at this point in the semester, because we just had to do so much more than that, but also use those skills. So the answer here is hopefully 3 comma 4. And you can check these answers by plugging in the 3 and the 4 into our original equations and seeing if they work out. Like negative 12 plus 24 really is 12. 6 plus 20 really is 26. So looks like we did it right. And whenever it comes to a big test that's worth a lot of points, it is a good idea to check your answer. This last section for my test says that you have to complete one of the 4, and anything extra you do can count as extra credit, or it could be that if you get all of the word problems right, that could help if you got other problems wrong, that sort of thing. So in this first one, 2 students decide to see who can read more books this school year. And the following table relates their progress over months. And so they have already started at the time of the contest with an amount of books read. So keep that in mind, because otherwise this doesn't make sense. So the equation for the books read by Timothy is that he is reading 2 each month. And so he's going up by 2. Sorry, pin struggles. Let me find a good one here. Okay, he's going up by 2. If I go backwards, then that means that at 0, it would be at 1. And the reason that's helpful is that 2 books per 1 month is my slope. If I wanted to, I could use x, or I could use a t here. Like maybe it's t of t for Timothy over time, which you're going to be like, why did you pick that? And literally, I could have picked any letters I wanted to, including y and x, if that would make you feel better. But then the y-intercept is 1 because we want to think about, well, what would they have started off with at 0? So we go backwards with our pattern to see that. And that's very similar to what we did with our explicit rule earlier. doesn't matter to me which way you want to write this, but if I'm doing a similar thing to T of t being Timothy over time, then L of t is Lily over time. So she's going up by 1, and if I go backwards, that means that she started at 9. So she has quite the lead. So 1t plus 9, or just t plus 9. Or if you want to be boring and use x and y, you'd get this. Part C says, solve the system of equations you found in part A and B. How long will it take for Timothy and Lily to have read the same number of books, and how many books will that be? So to solve these systems, essentially what we want to do, or one of the easiest things to do, is to actually set them equal to each other like this. Or you can subtract them. You can multiply one of them by a -1 and then add our equations together using elimination. It's totally up to you which you think is easier. I love using elimination. It is definitely my favorite, but if they're both equal to y and I don't want to graph because there's not fractions, then I'm totally going to use substitution every single time. So x is 8, or maybe it would have been better to use the t's so I would know that I'm talking about time. So when it's a word problem, you should answer with words. It takes 8 months for them to both read and how many books is that? We would plug it into one of these, like 8 plus 9 is 17, so 17 books. The key things that a teacher would look for is that you're using the units, months, and books, and you're somehow getting the point across that it's the same for both of them. So that sort of thing. All right, we are going to look at number 2. This is a graph, and we are writing the functions represented by the graph. And then, and so they give us, they named this one f of t, this blue line. So let me just switch to a nice color blue. So f of t, this is similar to what we just did. We need the slope for the blue line, which is from this point to this point. How much am I rising and how much am I running? Or use the slope formula, y2 minus y1 over x2 minus x1, or somehow we've got to come up with how much has it changed from 0,5 to 5 over 15. But we do that by looking at the up and down change over the left to right change. So the up and down change is the 5 and the 15. We're going to do 15 minus 5. And then the left and right change is 5 minus 0. So that gives me 10 over 5, which is 2. So the slope for this one is 2. I'm going to use t because that's the variable for f of t inside. So that's how we know what to use. Then our y-intercept is coming from this point. 0, 5 means that 5 is the y-intercept. So that's the first function, f of t. Now I'm going to do g of t in green. So g of t equals, same process of finding the slope, but now I'm going to use this point and this point. Notice they both go through this point. And so I'm going to go from 10 to 15 is up 5. And then from 0 to 5 is also 5. And so that simplifies to be 1. So that's just 1t. And the y-intercept there is 10. So here's my 2 functions. What does each function represent? What does the variable represent? So this is where we have to look at the side of our graph, because our variable t represents the time that has passed in days, because this axis down here is really the t-axis, because t is acting like x. And so the function itself, f of t, is like our y value and is representing episodes watched. So the function represents how many episodes have been watched the variable t, not enough space really here, represents how many days have passed, or something like that, or just how many days. All right, then part C says solve the system. Is the intersection point shown on the graph correct? So if I set these equal to each other or do elimination, and when we do that, we are thinking of this and this as being equal, like they're both y's or something, because that's the whole point. We want to know when are these equal? When are they the same point? So choose your method that you like. Again, I'm going to pick substitution because it's so easy to set them equal to each other and then move the t's to one side and the numbers to the other. And that gives me t equals 5. So if t equals 5 and I plug that back in here, for instance, 5 plus 10 equals 15. So yes, the intersection point is correct. So those two problems were take like systems of equations and writing stuff in slope-intercept form, so they're kind of a lot. Number 3, so you have to pick one of these last 4. Number 3, a classmate has just solved an equation without checking their answer. The solution has several mistakes. Without actually sitting here and redoing the entire problem, go through each step and explain how the step was obtained. If the step is incorrect, explain the error and the procedure that should have been followed. So here's the kind of thing that I am looking for. So this is the original equation. And so there's not really anything required for this. Let's look at how it changed from this original equation to this. So what did they do to get from the first one to the second one? They distributed the 2/5. So did they do that correctly? 2/5 times 10 over 1, you'd cancel a 5 out and get 4, so 4x, that's good. And then 15 over 1 times 2/5, you'd cancel the 5s and get 3 times 2, which is 6. So that's good. So this looks correct so far, which is, I think, funny because of all the places to not mess up fractions. Yeah. All right, so what would be, like, how would they have gotten the next step? So you can see that the 8x and the 11 aren't changed and the 6 isn't changed, but somehow 3 plus 4x became 7x. So can you understand how somebody would have mistakenly put that? 3 plus 4x equals 7x. So that is incorrect on step 3 here. And so the error is that they added 3 and 4x, which are not like terms. And what they should have done was add the 3 and the 6. Instead. So that's the thing that you're trying to figure out here, is what did they do and why was that not right, and then what should they have done instead. Well, now that they've done that, let's look for errors, assuming, like, we're going to pretend like they're right. Like, if this was right, then what would the correct next step be? So we've got 7x plus 6 equals 8x plus 11. The 6 and the 11 are still there. They've done something to combine the 8x and the 7x. If I subtract the 8x over, though, I don't get 15. So it looks like they just added 8x over, which is not the appropriate rules of equations. They added 8x over, which, when they should have subtracted and then something like, because adding doesn't actually cancel out the 8x. So something to that effect. So that's how that ended up being wrong. Let's see on this next one. So the 15x, that stayed the same. You'd subtract the 6 over it and get 5, so that's right. So this step was correct. And again, we're like checking for other errors in what they did, even though in reality it would have been better to be like, hey, here's where you messed up. Try to do it again or something like that. Now, x equals 3, that's incorrect because right here you'd want to divide both sides by 15, and 5 over 15 is not 3, it's 1/3. So they did 15 divided by 5 instead of 5 divided by 15. And it may be that they even tried to divide by 15, but they just thought of it backwards. So, so this is a case where you have to divide by the number in front of x. And so our answers here can vary a little bit because you can say the same thing with different words, but something to this effect is what I would be looking for on this problem. And finally, and this is going to throw us all the way back to 1.2, we went outside and measured shadows on the playground in order to estimate height. So a model of a plane is 22.5 inches long. So it's not a real plane, it's like a miniature plane. It's 22.5 inches long. The scale of the model to the original is 3 inches to 28 feet. And so instead of just asking you to find the length of the plane, I made it A, B, and C so that I can guide you through it. So the actual length of the model is 22.5, so that goes here. And the scale of the model to the original is 3 inches to 28 feet. So the 3 inches, which this was inches, the 3 inches should go up here. I don't know why I spelled it out. And the 28 feet should go down here. Because for every 3 inches in the model, we should have 28 feet for our plane. What we don't know, and what we're going to try to find, is the actual length of the plane. When you set up a proportion, there's more than one way to do it. I can put it just like how the table looks, and that will work. Or you can actually rearrange it. You can put the two model on one, the model information on one, and then the plane information on the other. What matters is that we match up information so that vertically we have similar information and horizontally we have similar information. Now I'm ready to cross multiply. So that's to do part C, which says to solve the proportion. Oh, 28 times 22.5. This sounds like a terrible thing to have to add. Not add, multiply. It'd be fine to add. I'm actually typing it into a calculator. That's 630. And so then I would divide both sides by 3 and get x equals 210. And since this is talking about plane length, and our length for our plane was in feet, x equals 210 feet. So hopefully no errors along the way here. This is our review, and happy studying.